Welcome to the Digital System Design Laboratory. So in the today's video, we are going to conduct our another experiment. And the objective of this experiment is to design the SR and D latch using Nand oblique NOR gate and to verify their function table. So let's start how to implement this SR latch and D latch, okay, using this Nand and NOR gate. So basically this SR latch, which is also known as set reset latch, okay, so it can be implemented by using either NOR gate, or it can also be implemented by using the NAND gate. So basically we have to take the two NOR gate, which is cross coupled to each other, okay, and then we have to make a proper set of connections to get the output. So here you can see that in this case, which is a latch, SR latch, made up of using the NOR gate. So here we can see we are having two NOR gates which are actually cross coupled. So basically, as we know that in the case of NOR gate, we are having the two inputs, okay, and one output pin. Okay, so here we can see that the output of one of the NOR gate is actually connected to one of the input pin to the second NOR gate. Okay, similarly, the output of the second NOR gate is actually connected to one of the input pin of our first NOR gate. So this way we have to make a cross coupled connection of this two NOR gate. And then we have to apply a proper set of inputs to these two remaining pins so that a particular function can be obtained. So obviously it can be understood from this particular circuit diagram that we can have the two outputs, which is referred here as the Q and Q bar. Okay. So basically when we have any latch circuit, okay, so first of all, we have to give this particular name. We have to identify which particular output you are taking as Q or which particular output you are taking as the Q bar. So for example, here, if it is a particular circuit, you can see if we regarded this as a Q, we have regarded this particular output as a Q bar. But whenever you are making a circuit, you remember that time any of them you can regard as the Q and the other one must be regarded as the Q bar. For example, you can make this pin also as a Q, and this pin can also be act as a Q bar. So this way you can designate any of the pin as Q and Q bar. But one thing that you have to remember is the function of our latch is such that these two output should be complement to each other. And let us suppose that if you consider that this output is Q and this output is Q bar, then there will be a certain set of inputs that is going to give a certain output to this particular pins. So those set of inputs that we have to apply, that we are going to apply, that is making this Q and Q bar equals to 1 and 0, okay, that is known as your set inputs. Okay, so for example, here you can see that if the Q is 1, obviously Q dash should be 0, okay, because this output has to be complement to your Q. So whatever be the input combination that we are going to give that drive this output Q to high and Q bar to low is known as your set input conditions. Okay, so here you can note down that when we make S equals to 1, okay, as you know that it is a NOR gate. So in the normally the NOR gate, if you see its a Boolean function, it is nothing but your A plus B complement, okay, whole complement, A plus B whole complement. So you remember that when we have the two inputs, okay, if one of the input is high, then the output will be 0. Okay, it is obviously going to be 0 irrespective of the value of the other input, because its Boolean function for your NOR gate is A plus B whole complement. Okay, so if A becomes 1 or B becomes 1, in that case the output will always be 0. So let us say if we make S equals to 1, in that case the output of this particular NOR gate will become 0, and this 0 is going to apply to this particular input. Okay, And that way you can see if this is input 0, and even if you apply r equals to 0, okay, then this combination drive this output equals to 1. So here you can see this first output, okay, when we are making s equals to 1, r equals to 0. In that case, this q is going to be 1 and q bar equals to 0. Similarly, in the next case, okay, once you have applied this 1 and 0, the output condition will be 1 and 0. If you make this combination, means if you make this combination s and r equals to 0, 0, just after applying the 1, 0 input combination, the output will remain same. Okay, the output condition is not going to be changed, and this will be your latched condition or hold condition. Okay, the output will be latched to your previous state. That you have to remember. Okay, so when you make it 0, 0 after applying 1, 0 combination, it will remain at 1, 0. Okay, so after s equals to 1 and r equals to 0, if you apply this combination, this has to be remain at 1 and 0. Now, if you apply, let us say, your first input combination, let's say if it is 0, 1, okay, even after this 0, 0 combination, if you apply 0, 1, okay, if you wish that this output q should go low, okay, it should go to 0, at that time you have to apply r equals to 1 and your s equals to 0. Okay, so when you apply r equals to 1, you know that because one of the input to this NOR gate is equals to 1, that time this q will become 0. And that time this 0 will be applied to this particular input, and this 0 and 0 combination will drive this output to equals to 1. And therefore, you are going to get this 0, 1 whenever your input conditions s and r equals to 0, 1, the output will be 0 and 1. And that time your latch is called in the reset mode. Okay, it will be in the reset mode. Okay, when it will be set mode, when q is equals to 1 and q bar equals to 0. So this will be your set mode and this will be your reset mode. So again, if you make this combination of your input after resetting your flip-flop, okay, if you make it 0, 0, the output will remain in its reset mode. It is not going to change. You remember this. Okay, it is 0 and 1. So it will be remain 0, 1. It will not going to change. Now, one more conditions or more input combinations that we may apply is your s equals to 1 and r equals to 1. Okay. So normally, if you apply s equals to 1 and r equals to 1, then you see, because one of the input for both this NOR gate is equals to 1, the output of both the NOR gate is becoming 0 and 0. So see, because the SR latch, what we have to get is we want to get Q and Q bar should be complement to each other. So because when we have this input conditions s equals to 1 and r equals to 1, this both the outputs are same. Okay, both the outputs are same, and which is equals to 0, 0. And normally this is not the case that we want. Okay, and therefore this is referred as the forbidden combination, forbidden state. Okay, it is the forbidden conditions because both the outputs are becoming 0, 0 and both the outputs are not complement to each other. You remember that if you simultaneously making this s and r equals to 0, 0. Okay, you remember whenever you are applying in this particular sequence, okay, at that time this 0, 0 means it is holding the previous state. Okay, it is holding the previous state, right? In both the conditions you can see it is 0, 0. It was holding this previous state 1, 0. Okay, so output remains 1, 0. Here again you can see that when we have applied this particular combination 0, 0, it is again holding the previous state, which is your 0, 1. Okay, it is 0, 1. So basically this is equals to your holding state. But generally what happens if you apply simultaneously 0, 0, okay, then this output will go to some indeterminate state. Okay, if simultaneously if you apply 0, 0, okay, at that time if you don't follow this particular sequence, then it will go to indeterminate state, and you won't be able to identify which output is going to be high and which output is going to be low. Okay, so that you remember, that is a very important thing. Similarly, we can also make the same latch using the NAND gate. Okay, so if you see this NAND gate latch again, you have to first identify which output you want to say as Q and which particular output you want to say as Q bar. Okay, so here let us say that this output we referred as Q and this output we referred as Q bar. Then you remember, as I said, that when Q is equals to 1 and Q bar is equals to 0, that time we said that this particular latch is in the set condition. Okay, so here you can see in this particular case, if this is the case, okay, 1 and 0, which is your set mode. Okay, this is our set condition of your latch, right? 1 0. So here you can see that to get this set mode 1 0, okay, here you can see what input conditions that we need to apply. Okay, so here we have just altered this naming. Okay, here we have this set mode, okay, S, and here we have this R. Fine, so this is set and this is R. Okay, means reset. Okay, so S and R naming is here like this. Otherwise here we have just reversed this naming conventions, okay, based on this particular conditions. Okay, so here you can see when we have applied this 0 and 1 condition. Okay, 0 and 1 condition, because if you apply a certain inputs, because we are now we are using the NAND gate. Okay, we are using the NAND gate. You remember, whenever we apply one of the input to this particular NAND gate equals to 0, okay, that will drive the output of this NAND gate to your 1. Okay, it will be making this output equals to 1, because what is the Boolean expression for your NAND gate? It is A dot B whole bar. Okay, so it is A dot B whole bar. So whenever one of the input to this NAND gate is equals to 0, the output is going to be 1. So basically here, that's why we have made this as a set condition. Okay, why we are calling this particular pin as a set condition? Because if we apply 0 at this point, this is going to make this output equals to 1, and this 1 is going to be applied to this particular input. Okay, and then we apply the 0. If we apply here like 1, okay, then 1 and 1 will be giving you output equals to 0. Okay, because 1.1 whole bar is going to give you output equals to 0, and that time it is having this output equals to 1 0. So that will be your set condition. Okay, so remember why we are calling this as set and here it is reset, because we are calling this output as equals to Q, or this output is equals to Q dash. If you change the convention, let us say if you call this as a Q and if you call this as a Q dash, that time this pin will also means interchange. Okay, we can call this as a set and this will become our reset pin. Okay, if you change this condition. Okay, if you call this as a Q and if you call this as a Q bar. Okay, so remember this thing. Okay, because this is very important to understand which one we are calling as set and which one we are calling as the reset. Okay, so this way here you can identify all this combination. Okay, if you make it s equals to 1 and 0, so here if you apply 0, you see that this Q bar will become 1. Okay, and this 1 and 1 will be applied, so this will become 0. So at this condition, the Q is equals to 0 and Q dash will be equals to 1. And if you apply 1 1 to both the input pins, at that time it is going to hold our previous state. Okay, it is going to hold our previous state. So it is holding this particular 0 1. So you remember that in the case of NOR latch, this 0 0 is acting as a hold state or latch state. Okay, and here it is 1 1, which is actually holding the previous state. Okay, similarly if you apply 0 1, okay, at that time this output, as I explained, okay, it will become 1 0, and once again if you apply 1 and 1, it is going to give you output equals to 1 0. Okay, similarly if you apply 0 0, okay, if you apply this set input equals to 0, irrespective of the input to the other pin, the output is going to be high. Similarly if R equals to 0, again this output is going to be high, because both the outputs are going to be high. Okay, again this two outputs are not complement to each other, and this is the condition of your forbidden state. Okay, so it will again become this particular combination will become the forbidden state, because your output is nothing but your 1 1. So the same thing we can also test, okay, onto MultiSim. Okay, and before that, here you can see, because here if you make a comparison, okay, here if you see for this particular NOR latch, when we are giving s equals to 1, okay, and R equals to 0, okay, in that case, we are getting our set condition, okay, 1, 0. We are getting the set condition 1, 0 when S equals to 1 and R equals to 0. Similarly, here you can see when we are giving 0 and 1, okay, when R is equals to 1, we are getting this particular output equals to reset condition 0, 1, okay. So our Q becomes 0 and Q bar becomes 1. And therefore, this is referred as generally SR latch, okay. And you can see its graphic symbol SR latch, okay. We referred like this, okay. We have this particular block. We are having one output, okay, and one another complemented output, okay. And then we are having this S input and R inputs. So this way we are having this our graphic symbol of our SR latch, okay. But if you see in the case of NAND SR latch, this is also another important thing that you have to remember, okay, that here you can see when we have to drive this particular NAND latch into your set conditions, the input conditions to S and R is 0 and 1. Here you can see it is 0 and 1. Okay, that time over, your means NAND latch is going to into the set condition 1 and 0. When it is 1 and 0 conditions, it will be going to be reset. Okay, it will be in the reset state. Okay, and therefore, generally, we normally call it as SR latch, but you remember it is also referred as S prime R prime latch. Okay, it is also referred as S complement or R complement latch. Why? Because we have to the input conditions are just complemented is with respect to your NOR latch. Okay, here S is 1, so Q becomes 1, and when it is R is 1, Q bar become 1. Okay, that is the condition. But here the condition have just reversed. Okay, when S is equals to 1, the Q is actually 0. When R is equals to 1, your Q dash is becoming 0. Okay? So this way you have to remember this. Okay. So you can see because it is your S bar R bar latch, the graphic symbol generally for your NAND latch is this. Okay, is S bar R bar, and here you will find one bubble. Okay, in front of your S and R. Okay, that referred it is automatically you can understand that this graphic symbol is representing your NAND SR latch. Fine. Similarly, you can also make this D latch. Okay, with enable input. Okay. So it will be again having a cross-coupled NOR gate and NAND gate. Even you can take the NOR gate, but here we have shown this circuit by using the NAND gate. Okay, and then if you also want to have a particular enable input, okay, we can take another two NAND gate in this way, and then we can also connect one enable input pin. Okay, and then we have to apply our D input to one of this particular NAND gate, and the complemented D means D bar input to another NAND gate. Okay, this way we have to apply the input, and then you can identify what will be the output. Okay, it is very simple to analyze. Okay, you can do this analysis whenever your enable pin is equals to 0, whatever be the input D, the output is not going to change because of the change in the input D whenever enable pin is not enabled. Okay, it means if enable equals to 0, you see whenever you are applying 0 to this particular input pin, irrespective of the value of D, the output of both this NAND gate is going to be 1. Okay, it is going to be 1. And when it is 1, 1 input, okay, you can see it is a hold state. Okay, whenever it is 1, 1, it is going to be the hold state. So it is going to hold the previous state that you remember. Okay, so it is also always going to be holding the state. And whenever enable pin is equals to 1, that time if you make D equals to high, that time this Q will become high. When D equals to low, this Q will become low. So generally it is also referred as the transparent latch. So now we have to see how this particular latch can be implemented onto the MultiSim. The same you can also implement to your lab. Okay, so let's go to this MultiSim software. Okay, so this is our circuit. So I have here, just for the simplicity, I have taken the discrete NOR component and NAND component. But you remember while performing the experiment in laboratory, we have to take the IC. Okay, 7402 IC, and then you have to make the proper connection to its power supply, and also to the you have to make the ground this particular IC. Okay, the IC that you are going to use, you have to make the connection to the ground. So now here you can see I have just made the connection as per the diagram. Okay, it is our cross coupled NOR gate. Here you can see now we have to verify the function table of our this particular NOR latch. Okay, so let's try to see this. The first combination that we have to apply is we have to make the set equals to 1 and R equals to 0. I'm just applying the first combination first. Okay, so let me make this R equals to 0. Okay, so now first I have made S equals to 1 and R equals to 0. Now we have to execute this circuit. Let us say that this output is Q and this output is Q bar. Now if you execute this one, okay, because it has to go to the set condition, okay, this LED should glow and this LED should not glow. Okay, so if you execute it, here you can see that this LED is actually now glowing. Okay, so now it is in the set mode. Now while executing this circuit, okay, we don't have to turn it off. Okay, you remember that it is a latch. Okay, you cannot turn it off. Okay, so you have to apply the input in a particular sequence. Okay, so now once this is our in the set mode condition, okay, here you can see this. When it is in the set mode condition, okay, if you want to hold the same condition, okay, we have to apply the 0, 0. Okay, so let me just apply the 0, 0. Okay, if I make this S equals to 0, it will be holding the previous state. So just I'm making S equals to 0. Here you can see this this previous state is now actually it is holding. Okay, it is holding the previous state. Now if you want to make it reset, okay, if you send this particular latch into the reset mode, you just try to make this R equals to 1. Okay, so if you make this R equals to 1, okay, just to see this changes. Okay, if you make this R equals to 1, it is going to the reset mode. Okay, this particular Q becomes 0 and this Q bar becomes 1. So again, if now it is in the reset mode, if you want to hold the same condition, okay, then again you can make this both the inputs equals to 0, 0. Okay, because 0, 0 is our corresponding to hold state. So if you make this equals to 0, you just note down this particular, notice this change. Okay, if you make R equals to 0, okay, try to make this R equals to 0. Okay, the previous state is now actually it is holding. Okay, previously we have noted that when it was 0, 0, it was holding this particular state. Okay, it was in the set mode. Now it is in the reset mode, and now again it is holding the reset mode. Okay, now from here itself, what we can notice is, okay, if I make a changes, okay, let's try to see this. Okay, let's try to see this. If we make it 1, 1, if we make both the inputs equals to 1, 1, then it should go to the forbidden state, which is corresponding to 0, 0. Okay, so let's make let me make this both equals to 1, 1. Okay, I'm just changing both the inputs simultaneously. Okay, I'm just making it 1, 1. Okay, you try to see this output. Okay, this is 1 and 1 we have applied, and both the output is 0, 0. Okay, it means that both the outputs are not complement to each other, and therefore it is in the forbidden state. Now you remember, if now I am applying both the inputs equals to 0, 0 simultaneously, okay, that time I said that the output is going to be indeterminate state. You cannot determine which particular LED will first glow. Okay, you cannot determine it. So I'm just trying to apply 0, 0 condition, okay, simultaneously. Let's try to see this condition. Okay, so here you can see that both the LEDs actually now blinking. Okay, so now it has entered into the indeterminate state and cannot decide what will be the state. Okay, so again, if you wish to make it set, okay, you have to apply S equals to 1. So once you will apply S equals to 1, it is going to be set condition. Okay, and if you wish to again hold the same state, you have to make S equals to 0. If you make want to reset this particular, you have to apply R equals to 1. This way you can test your circuit. Okay, now I'm just going to test the other circuit. Okay, our Nand latch. So try to see this Nand latch. Okay, I'm just stopping it. Okay, I'm just making this, I'm just disconnecting this one so that you concentrate upon the Nand latch only. I'm just making this connection. Okay, so just make this connection and try to see this differences. Okay, so now here you can see this is our S and this is our R. Okay, So now try to see this one. Okay, this one. Okay, this is our S, this is our R. So now we have to test all this combination. For 1 0, it is going to be in the reset mode. Okay, you remember that in the case of NAND latch. Okay, when it is 1 0 will be a condition, it should go to the reset mode. Okay, so let me execute this one. So here you can see that it is in the reset mode. Okay, it is in the reset mode. This particular output is glowing. This is your 0. Okay, so again, if you wish to hold the same condition, previous state, you remember that in the case of NAND latch, both the input condition should be 1 1. So I'm just making R equals to 1. Okay, so if you make this R equals to 1, it is holding the previous state. Okay, now if you want to make the changes, okay, if you want to set this particular NAND latch, at that time we have to apply S equals to 0 and R equals to 1. So if you make S equals to 0, you can see this. Now we have set this particular your NAND latch. Okay, so this way it is in the set mode. Now again, you can hold this particular state. If you make S equals to 1, it will be holding the same state. Right? Again, if you make this S and R equals to 0 0, here you can see this particular case S and R equals to 0 0. The output should be going to be 1 1. Okay, both the output will become same. Means it is not means complement to each other, and it will be entered into your forbidden state. Okay, so let's see this one. If you make S and R both simultaneous equals to 0. Okay, I'm just making it 0. Okay, you can see both the outputs are equals to now 1 1. Okay, which is nothing but your forbidden state. The same thing if you apply S and R equals to 1 1 simultaneously now, then it will enter into the indeterminate state. Okay, you cannot identify which output should be 0, which output should be 1. So let me make it simultaneous equals to 1 1. I'm just making it like this. Okay, so you can see both these outputs are now in the indeterminate state. Okay, it is indeterminate. You cannot identify. Okay, now if you again, if you want to set this particular output, so what should be the input condition? 0 and 1. Okay, so I'm just making S equals to 0. It is now in the set mode. So this way you can test all the combinations. Okay, similarly you can also test your D latch. Okay, this is our D latch, whatever the circuit I have shown. Okay, remember that you have to use one inverter circuit also. Okay, 7404. So that IC you have to also use. Okay, in this case. And here again, you can see a very simple circuit that you can implement. You can execute this circuit. Okay, here you can see that when this enable input is equals to 0. Okay, this is our enable input equals to 0. Fine. So let us say when this is equals to 0, here you can see whenever it is in the 0 state. Okay, whatever be the input state, there should be no change. Okay, so let me again just do it again. Okay, let me first make E equals to 1. So if I make it equals to 1, okay, now it is this key is means your enable input is equals to 1. So now in this case, whatever be the input D, that will be the going to be the output as Q. Okay, so here you can see what will be the output. So you can see this whenever this enable input 1, then at time if D equals to 0, the output should be in the 0. Okay, it will be in the reset state. When this D equals to 1, it will be in the set state. Okay, the same thing that we can see here. Okay, when D equals to 0, the output is 0. When we make D equals to 1, okay, it will be in the set mode. Okay, it is in the set mode. Fine. So that you can make changes. D0, it is in the reset mode. When D equals to 1, it is in the set mode. Okay, similarly, when it is already in the set or reset mode, if you change the enable, okay, if you change the enable, let us say if you change the enable, right now enable is equals to 1. If you make enable equals to 0, let's say if you make enable equals to 0, it is going to hold your previous state. Okay, the previous state is the set mode. Okay, if you make it equals to 0, now I have made equals to 0, you can see it is holding the previous state. Okay, it is holding the previous state. If you make changes in the D now, there will be no effect in this output. Okay, I'm just making D equals to 0. You can notice here I have made D equals to 0, but there is no change. Okay, there is no change. If you make D equals to 1, again there is no change. Okay, because it is holding the previous state. Again, you can see if I make like enable equals to 1. Okay, if you make enable equals to 1, Okay. If now you make d equals to 0, okay, if you make d equals to 0, the changes will appear. Okay, you can see if you make d equals to 0, this is in the reset mode. Again, if you make enable equals to 0, and if you make the changes in the d, okay, there will be no effect in the output, you can observe. Okay, you just, I'm making d equals to 1, there is no change. Okay, if you make d equals to 0, there is no change. Okay. So this way you can identify, you can realize this all latch circuit in your laboratory, and you can verify its function. Hopefully you must have understood how to implement this circuit. Okay, if you have any further query, let me know with your comments, okay, in the chat, in the comment box. So thank you for watching this video, and stay connected for the more updates. Thank you.